Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience and tuning back in this week. For those new to the show, my name is Shawn of Insights in Automation, and each week I invite a new vendor on the show to tell us about their products and technologies. And during their presentation, I play the role of the audience, asking questions that I think you might have, as well as questions that I have. With that said, I want to welcome our guests today on the show. We have Jay, Charles, and Nick from Schneider Electric, and they're here to talk to us about VFDs. And I'm going to start by sending it over to Jay and asking him to introduce himself, and then we'll ask everybody to go around the room here and introduce themselves to the audience. Go ahead, Jay.
Shawn, thank you again. I am super excited to continue my journey here, providing more Schneider Electric content to all of our listeners, though. And a quick intro, like Shawn said, my name is Jay Cortel. I am an applications engineering manager at Schneider Electric. I have over 25 years of automation experience, and I'm here representing all of our OEM IA organization by gathering all the top engineers I can get in one room to discuss both turnkey and individual offerings for a machine solutions lineup. Because I'm too old to try to remember and I'll do it myself, I bring the big guys in. Recap. If I counted correctly, this is our third podcast with Shawn. Podcast number P61 was based on Monicon PLCs. Podcast number 2, which we just released, P176, was on our Harmony line of HMIs. So, with further ado, I have two amazing PEs from our Drives organization, and I will let them continue forward. I will start with Nick.
Yeah, thanks, Jay. So, appreciate you having us here, Shawn. And my name is Nicolas Rosner, or Nick. I am the Schneider Senior Drives Offer Manager for Altivar Machines and Buildings. And I've been with Schneider Electric for about 2 years now, 14 years in the industry. With the team here, I also have Charlie Adkins. So Charlie, please go ahead and present yourself.
So yeah, thanks Shawn. Really appreciate you having us on. I'm Charlie, and I'm among other things an application engineer. I started with Schneider, I guess, about 7 years ago, and before that, I've been doing controls work and drives work and stuff since I don't even want to admit, I think like 91, 90. So I'm bad at math. You can figure that out. Yeah, and Nick just got the big promotion to the offer manager. He used to be one of us in the trenches. So, everybody wish him good luck with that.
Yeah, appreciate that, Charlie. And just to clarify, I'm sure he meant 1991, not 91 years old.
I'm not quite that old yet.
Appreciate it, Charlie. So okay. With that, let's go ahead and start here. We're going to present the Schneider Drives family. And obviously, we have everything for customers, from machinery to buildings, soft starters, process, and medium voltage drives. The focus of this presentation is going to be the Altivar machine drives. At some other point in the future, happy to discuss some of the other offerings here. But for this presentation and for the audience, we're going to focus on simple and advanced machines and the solutions that we have for a lot of those segments in the automation world. So if we go more forward here, you see the drive family that's specific for machines. It's the 12, the 320, and the 340. We do packaging, material handling, textile, material working, mechanical, and hoisting. So depending on which industry focus we have, either we're tying in through a DC bus, induction motor, a synchronous motor. We're going to go through the details on which drive is most appropriate for your needs and for your machinery and automation. One of the biggest highlights for Schneider Electric is that we have software that is free. It's downloadable via internet. So we have a link here that I'm happy to share. You can just Google SoMove. The SoMove is an amazing drive tool for all drives family, including some of our servos here. You can upload and download configurations. You can configure drives offline. You can actually download the files here onto the simple loaders or multi-loaders that work with our machinery drives if you want to mass program a lot of these on the shelf, even while they're turned off. We have simple loaders and multi-loaders that can be pre-programmed via your computer here. We can run this through the PC. We monitor functions. We even have a scope. So for some of these extremely complex applications, think of like permanent magnet motors. This is just an amazing tool to have to be able to look at the auto tune and adjust some of the very like niche parameters that we have for those types of applications. We have embedded drive manuals in the system. We have access to this via Bluetooth, Ethernet, serial Modbus. My preferred way to connect to the SoMove is via the Modbus cable that we show here. And if you stick around all the way to the end, Charlie's going to run a simulation of how amazing this tool is. So with that, let's jump into our machinery offer. I will focus on the Altivar 12 for basic machinery requirements, and then talk about the 320 that's for simple and advanced machines. Charlie will go and do a deep dive on his favorite VFD, the Altivar 340. And if you want to have a overview of the machinery drive families here, this are the horsepower ranges. As you see here, this is the Altivar 12, a very great simple drive. Single to three-phase motors, 120, 230 single phase, and 230 three-phase. It is just an amazing VFD. We can actually get it in base plate as well. We have a lot of these drives readily available in stock, which is excellent for a lot of our machinery panels and OEMs. And these are rated for machinery type applications. So as you see here, 60 CD rating, 3C3 environmental, which Charlie's going to go in deep dive later on, and up to 60C with D rating, 50 without. So on the Altivar 320, we have a little bit more flexibility here, can do both simple and advanced machines. It has a book format, which I will show you later on what that means. Excellent for very compact type panels and still be able to meet the heat dissipation requirements. The 320 that also comes in an IP65 and IP66 for certain horsepowers, and we call these the bookshelf versus the compact. So permanent magnet motor control is available on the 320 and the 340. That's the PM-SM control. And then we have many more communications on the 320 or 340. So as you see here, Modbus and CAN open for the 320. The 340 starts going into Ethernet IP, even on board circles, TCP, so that we have different bills that have these standard, or you can have just a Modbus and have the options below here. The 320, something unique about it is that other than all these safety functions that are already on board for your applications, has something called an ATV logic. So if you have simple Boolean, simple math applications, time delays that you want to program onto your VFD application, the ATV 320 is the way to go. Now let's move on to what each drive family does for you. So 12 is the best drive for simple machines. It has the accessibility to SoMove, really great PID loop to control applications. So I've done some excellent PID type, for example, fan exhaust and whatnot. But for single to three phase and to a 230, as you see here, start, stop, DIs for them, one analog input, one analog output, a relay output, transistor output, and really it's a standard basic drive that will do a lot of flexibility with SoMove and other things. Great starter VFD for machines. Now the 320 can be used for both simple and advanced machines, and we'll go as to the details why it's a little bit different than the 12. I mentioned before, permanent magnet control is one of the things that this is a great application for. More comms, as the 12 only had a Modbus, so simple again versus a little bit more advanced. The ATV logic, the safety functions, excellent algorithms for PM motors. So it has a really good auto-tune feature here for those applications. And with the SoMove, just great if you want to control the noise and just have a very smooth PM type application. Has a lot of safety functions embedded. And these are just the safety functions that are available. So if you want to do a deep dive, highly recommend that you go into the catalog so that you can program accordingly. And the safety features are here. So safe torque off, safe stop, safety speed limit. Again, this is just a great solution for you that you can go through the CAWA for the specifics that we can do. And you would do this via the SoMove software. Another thing that you have via the SoMove software is the 30 different function blocks via the ATV logic with your inputs and outputs. So think about your IOs being able to do Boolean with ones and zeros, program time delays. It's an embedded micro PLC inside of the drive. And this is the only Altivar Schneider drive family that offers that on the machinery side. And anything like below 10 ROMs, this is just a really great way to do some simple applications with time delays and then 4 registers. So going back as to why 2 form factors, you're going to see here the bookshelf style ATV 320. So you see that every single VFD stacked against each other still comply with the heat requirements and meet that compact panel solution. So not to say compact because compact is actually the other VFD. The compact form factor, which we call it, is the other solution that we have here. It does require some spacing. And I would say the biggest difference is that the compact can do 280/230 up to 20 horsepower versus the book only does that on the 480 3-phase and 280/230 single phase applications as well. I mentioned we also have the IP65 and IP66 with disconnect or without disconnect switch. All right, and we have here some comparisons so you can see how this goes against some of the other brands out there. This is really the best machinery VFD in the industry. So in terms of features, functions, look at everything that we have here compared to everybody else. This is really one of my favorite and preferred machine drives in the business. So with that, I will go to the 340. My colleague Charlie Adkins here is going to take over, and let's hear about your favorite VFD solution. Please go ahead, Charlie.
So Nick, I'm going to disagree with you just a little bit about the 320 being the best machine drive in the industry. I think this is the one. We introduced this drive in around 2017, and the story that I remember most about it was that one of our biggest customers, we presented this to them in Europe. You know, they were a big enough customer that we took them over to France and, you know, what things that you do in France. And they saw this drive and they said, okay, that's fantastic. We want to use that everywhere we have them. So the product managers over there said, well, okay, great. How many do you need? I said, well, we've got 4 or 5 projects coming up this year. We're going to need about 15,000. And the product manager kind of gulped and said, well, we were only going to ship 10,000 to the US in the first year of the release. And he said, great, we'll take them and get us the other 5. So it actually delayed the release of this drive in the States until 2018. So let me tell you why it's the go-to. First of all, it can do any kind of motors that are out there right now, commonly used, standard, you know, asynchronous induction motors, permanent magnet motors, and it also can do synchronous reluctance motors. Now, you may not have seen them around much yet. I haven't seen them in the States much, but it's if you want to go dig around and figure out what they are, it's a motor that's got a lot lower construction costs, so you're seeing them more in the industry. This thing has also got, out of the box, sensorless vector, closed loop vector, and then all the standard open loop features there. The other big advantage is if you are going to do closed loop vector, it already has an embedded encoder card in it. You can actually put another one in if you're doing speed following or those kind of things, but that's not extra. It comes with it. So all in one box. We also, let's see, I think it was 2021, released our new motor control algorithm, which we call adaptive cascade vector control, ACVC. I know they spent a lot of time coming up with that acronym. So, yeah, I mean, all around, this is a good go-to drive. So it sounds like I'm excited about it. It's probably because I am. Here's a list of a bunch of the embedded functions that are configurable. Most of them are for hoisting applications. So you're going to see on here the mechanical brake sequencing. We have rope slack detection, high-speed hoisting, weight estimation, and it's just a lot of features already built into it, along with all the standard stuff that you're used to seeing, like load sharing, torque limits, all of that business. So, harsh environment. Everybody says they have a robust drive, a robust system, and I have yet to see a unit of measurement for robustness. But the Europeans have a standard that they go with. Pretty much all of the drives that we have, I'm not sure about the 12, but we can check. Have what's called a 3C3 level with salt mist for chemical contamination, which is pretty much equivalent to being conformally coated, except for on steroids. It's got a lot more resistance to corrosive gases that you might have in your atmosphere. And then we also have a mechanical pollution of 3S2, which, it's a European thing, so they can't make it real straightforward, right? But that has to do with the size dust particles that are flying around in the air. 3S2 is for very fine particles, but it's still an indoor rating. So that is our level of robustitude. Is that a word? Anyway.
It is, Charlie. So the 12 does have the 3C3. Sorry to interrupt.
Excellent. Thank you. One of the other things that was important to this customer was being able to replace a drive that had failed in less than 5 minutes. So that's implemented by different manufacturers in different ways. But the way we get away with the way we do it, not get away with it, is all of the I/O terminals are pluggable up to a certain power range. The power terminals are pluggable as well. So you loosen up 4 screws, slide it out of the panel, put the new one in, and then if you go through the keypad and have it set up for the fast device replacement function, then the drive will go out to a server in a PLC and pull the configuration. So the maintenance guy doesn't have to sit there and fat finger in all the parameters for everything. You can also store the program in a keypad and download it directly from there as well. So you don't have to set up fast device replacement for this, but there's several ways to do it. As Nick mentioned, we have versions that have embedded Ethernet IP. We have an embedded Circos 3 network that lets you get on that motion control network, that real-time deterministic network that you see in a lot of high precision motion control stuff. It has an embedded web page that you can do pretty much whatever you want to with it. You can set it up for just monitoring. You can configure with it, whatever you want to do. All of them have safe torque off inputs. So when you're going for those higher levels of sill safety, that counts as one of the contactors because it shuts down the back end of the inverter. If you need some of the other safety functions like safe limited speed, car door locking, that kind of business, we have an optional card that you can stick in there and get those functions embedded. And new this year, we have a SIP safety version. It's an extra card that slides up in the bottom. and integrates with the M580 Schneider Monicon PLCs.
Now, let me
So-
ask a question. Can you have both
Yeah.
of those modules in at the same time, or is it one or the other?
So far as the safety module
Mhm.
or the SIP safety module,
Yeah.
you can only have one or the other of those.
Okay. Okay.
And in general, you can only have one communication card.
Okay. That
So
makes
there's
sense.
something because of how Circos works, there's some functions that don't really mesh up right. So,
Mhm.
but yeah. So
And with
far
some of
as
these, Sean and Charlie, they're also a dual port, so you can daisy chain. So even though it just has a one comp card option, just wanted to clarify.
right. So that was the next thing. These things do RSTP, so you can set up your network topology however you want. The Ethernet versions have 2 Ethernet ports. And all of them have as well 2 Modbus serial ports. Usually you use one of those for the display. And let's see, here's a picture of the displays you can get. The displays come in the big one. It's over on the left. So it's about, I don't know, 3 inches by 4 inches. It has more buttons than the little one, which is right next door. The little one will snap into the front of the drive, so you can just leave it there. Both of these displays can be mounted on the front of a panel, so you can fiddle with your drive without having to open the door. So another safety feature there. Added bonus, the mounting kit for both of these, because it plugs into one of the Modbus serial programming ports, you can also unhook the HMI, plug in your Modbus to USB secret decoder cable, and program your drive with SoMove. So, I mean, there's just a whole lot to these guys. Here's a rundown on the frame sizes. Now, all of these are just going to be 400-volt drives because that's the vast majority of the market that we're targeting and that we serve. So, and those markets are mainly material handling, package handling, and assembly type machines. So conveyors and that kind of business. So 480 volt, 1 to 100 horsepower. Side note, if you need above 100 horsepower, then we switch over to a different series that has a whole lot of the same functions, but it's our top of the line premier process drive. And those go up to 350, 400 horsepower. If you need bigger than that, call us. We can work something out. So all of these are rated for 150% overload for a minute. And most of them can do 180% for 2 seconds. Some of them can do 220%. So this guy has a whole full can of grunt embedded inside it. Should be plenty to get your business moving. So Nick mentioned SoMove a little bit earlier in the program, and I really want to hit this hard because this, as far as my experience goes, and as Nick helpfully pointed out, apparently I was working with George Westinghouse putting together the original power grid. This is best in class programming software for drives. It's one of the easiest ways that I can convince people to start using our stuff, because it's got all of the features of the top end paid drive programming softwares, but you can download this for free. It is a part of our larger programming package called SoMachine. This is basically a snap into that, another front end on it, so you don't get the PLC and the HMI stuff, but you get all of this. What that means is that this piece of software is live. It's not something that we stuck together in Visual Basic 3.0 and forgot about. It's constantly updated. The other cool thing about it is that this software will program pretty much anything that Schneider has built in the drive market for the past 20 years. So if you've got old 61, 71s, 31s, 312s, a lot of legacy stuff, you can program that stuff with it too. And let me switch over. So this is SoMachine. This is, again, just Google SoMachine and it'll take you to the download page. What I've got pulled up here is an ATV 340, one of my favorites. And let me just show you a couple of the things that I think makes it fantastic. If you go to this parameters list tab, it pulls up a menu tree over on the side. Now, here's the really cool thing that I use this for. This menu tree over on the side is the same layout as the menu tree in the HMI. So if I'm troubleshooting with somebody over the phone, then I can walk them to stuff that they need to get to. So, for instance, here is all our motor data. So if I need them to check this parameter, I said, well, you need to check the nominal motor current. They go, well, where's that? Okay, go up to the top, go to complete settings, motor parameters, motor data. There it is. Obvious, right?
Well, for the audio audience, I just want to throw this out there. What I like about this is not only do we have all the parameters, we have the current value, we have the default value. This is all like in an Excel spreadsheet look. We also have the minimum and maximum value as well as the logical address. So, I mean, everything's right here that I need. So I really like that. Back to you, Charlie.
No, that's fine. Yeah, and he did mention the logical address out there. That's the register. So if you want to hit that register across your network, that's your number right there. So as you can see, there's a billion, 627 million different parameters that you can adjust. So we did everybody another favor. We have the Simply Start menu, kind of a goofy name, but this is 95% of the stuff that you need to set up to get your drive running. So this is where you would put in your motor nameplate data, whether it's 2 or 3 wire control, that kind of thing, and the ramp times. So like I say, for most applications, this is all the important stuff, and it's all pulled up into one place. All of these parameters show up in other places in the menu, but again, they're collected here. Here's another fantastic thing: modified parameters. You can get to this through the HMI as well, not just through SoMove. But this is a list of all the parameters in your application that are not default. Nice. So yeah, so when things start going goofy, you can go over here and see who's been monkeying around and, gotten into the wrong place. But wait, there's more. We also have the next tab over, which is the parameters layout tab. And this is more of I kind of hate to use this term because it's pretty hackneyed. It's more of a wizard. Where, again, it's all the same parameters. It's just organized in ways with little pictures and things that help explain what those parameters are. So, here's our ramp settings. Here's our acceleration time. There's a little picture of it. One of the most confusing things that I've ever had to deal with anybody's drive is where are the references coming from? Where's my speed reference coming from? This is a graphical representation of how that flows. So for instance, if I wanted to switch between the Ethernet and I wanted to change to analog input 1 when I change digital input 3 for local or local remote control, I just did it.
Nice.
So, yeah. But when you're online with it, this signal path changes colors depending on which one is active. I mean, come on. This is free? We're giving this away? Yes, we are. Under the Diagnostics tab, and unfortunately, I don't have any errors loaded up here. But this is the fault history. We saved 25 faults in the drives. That time and date, if we have a real-time clock, so that's going to be the 340s and the process drives. And then what was happening at the time that fault occurred, where it was getting its speed reference from, what the DC bus voltage is, what the motor current was it accelerating, was it decelerating? All that is logged with every fault. So again, troubleshooting, maintenance, because I mean, let's face it, usually when drives stop working, they start throwing faults. It's really not a drive problem. It's really something that is going on outside of the drive. It's the motor leads are failing. The insulation's cracking over. You've got a power outage. All of this kind of stuff. So when you are logging all this data, it gives you a massive amount of information that you can troubleshoot with. Because again, taking a drive off the wall, putting it back on, starting it all back up, and the new one starts throwing the same fault, well, you were looking at the wrong problem, right? So again, I really do like this, and when most people see it, they get excited too. Nick also was talking about the oscilloscope, completely configurable, and you can, for instance, see what your actual speed versus your commanded speed response time is. We've got a couple of different ways that you can do that, but the sample rate on this, if you go to the internal recorder, goes down to 250 microseconds. I'm gonna say that again.
Amazing sampling rate. Yeah, I mean,
250 microseconds. And the way that works is when you set it up, the trigger fires, and the drive itself does all the logging, and then once it's done, it uploads it. So it can get a very, very high sample rate. If you're doing it over a network, then you're obviously at the mercy of whatever the speed of your network's going. That's
Did it
cool,
say,
right?
Charlie, up to 72 hours of recording sessions? So if you have issues at a site and want to figure out what's going on, when I'll leave it overnight, was that the upper limit? Just curious, right there.
If you are doing it over the network, you can do up to 3 days, but you can't. There's not that much storage inside the device itself. With that one, you can do a day, but the sample rate's like 100 seconds.
All right.
So there's only so much internal memory.
Yeah, thanks for clarifying. Just I think it's still pretty incredible to be able to do it either way
Oh
for
yeah.
that long of a time.
Oh yeah. So again, that's one of the biggest tools that we have for customers, OEMs, panel shops. It's, as we talked about, it's got a massive amount of troubleshooting with it. You can help people over the phone with it. If you can ping the drive, you can hook up to it. So I actually, a couple of years ago, I got roped into an application in a steel plant where they were setting up a lift, and they actually caught me on vacation. So I was sitting on the porch in my bathing suit at one of the lakes out here, with SoMove hooked up over my cell phone at at the other end, and I'm tuning this drive, and getting a massive 10. So you may not want to be able to tell people that you can do that, but you can.
Well, it's great for
Yeah.
troubleshooting. If you're you don't have any automation people in the plant and it's late at night,
Mhm.
if you can connect in via your VPN and
Right.
see what's tripping the drive, maybe you can tell the night electrician what to do and he can solve it without having to get your automation expert into the office. So no, that's great.
Yeah, yeah, exactly. Now, for the drives that have embedded web pages, you can do that without SoMove. So there's a couple options there. Um, just to kind of fill that part of it out, because security is a huge issue with the internet stuff. The web pages that we have, where they're embedded in the communication cards or the drives, come out of the box disabled, so you can't get to them. The only way that you can enable them is if you have physical access to the drive. So we follow past that what's called an Achilles level 3 cybersecurity standard protocol. And that always cracks me up. It's a third-party thing that it's the Achilles security standard, but it's basically the same protocol that is used for banking and other real high security data transfer stuff. So we're up there.
And then Shawn, just wanted to add one last thing, going back to helping our customers late at night or over the weekend. We have a tremendous resource called the Schneider FAQ, and that's really for old products. So I was able to help a customer out the other day, being able to get their ATV 340s on hand mode via the display keypad, and just following the instructions on the Schneider FAQ, myself going through the SoMove, walking through the parameters together, they were able to get their drive panels up and running for testing over the weekend. So there's just a tremendous amount of resources available for people that either through the SoMove or through our internet can really do a lot of self-help if that's what they wish to do. Go ahead, Charlie.
So the Altivar process drives are our top of the line drives. They have the same hardware features, but we break them up into two different categories, the 600s and the 900s. The 600s are pointed towards pump and fan applications. So think centrifugal pumps, big fans. They can also do constant torque applications because again they have the same power stage. They just have a different set of features in the firmware. So the 900s are for what I like to refer to as everything else. If it's a conveyor, a crusher, a centrifuge, all of this kind of stuff, this machinery things, it has a lot more embedded functions pointed at those applications. We've overbuilt these things like we always do. So it's a real solid power stage, real solid controls. But what we did on this version, as opposed to the last version, the 61s and 71s, was we built a whole lot more diagnostic stuff into the drive. Most of it goes through the that big keypad that I showed a little bit earlier. That works with all the process drives and the 340s. And like I say, you can look at all this stuff and see what all is available to you. What we're showing up here is a graphical representation of the pump performance. So in the 600s, we have a pump curve that you can set up that will show you where you're operating so far as best efficiency point with the pump. We also do energy logging if you want to know how much power you used over the last day, week, month, year. Here is the all the fault codes. When you throw a fault, you can pull up a QR code on the display scan it with your phone. It takes you to a web page that has troubleshooting information for that fault. If you don't have a phone, most of that troubleshooting information is already embedded in the HMI. So you can already start troubleshooting without a manual, without a smartphone. It's pretty powerful. You can also save programs in the HMI. And it's really, I don't know how you would fill it up. Previous versions that we had, you could save 5. This one has a couple of megabytes worth of memory. Each file is less than a kilobyte. So do the math. You can put every drive that you have in your facility on one HMI if you want to. There's several things here that are showing how the process drives can be connected. In the middle, we're showing what our web page looks like. Anywhere you can pull up a web page from, you can pull that up if you have it enabled. Here's more on the web server. And what we're showing here is how deep and connected you can get. Now, Jay might not be super excited about me saying this, but we connect very, very well. All of our drives connect very, very well with other people's PLCs. We'll call them third-party PLCs. To the point where we have several AOIs and snap-ins for brand A, B, C PLCs that you can rapidly develop your applications on those platforms. So the function blocks that you see here are for our PLCs, the Modicon PLCs, but we do have some stuff that you can use with other guys if you really feel like you have to. So again, here's kind of where we make the split in the process drives. Over here, we're showing stuff that's in pretty much everybody's drives. And then the functions that are specific to the 930, you're going to scan down here and see, a lot of hoisting stuff, and different machine kind of functions. And all the 600 stuff is pump and fan. So jockey pump control, cavitation protection, all that stuff. This is an example of the QR code and how that works when you throw a fault. You press a button on the HMI, pulls up a QR code that you can then pull up a web page for that individual fault. And just to kind of fill it all out, these are our enclosed drive systems. So these are assembled in North America for enclosed packages, type 1, type 12, 3R. You see these more in water, wastewater kind of environments. But yeah, we go from 1 to 1100 horsepower, and that's not even the top limit, because right now I'm quoting a low voltage drive that's, I think, 1800 horsepower for an extruder. So we pretty much have you covered. That's pretty much my cheerleading section. I'm going to kind of throw it back to the big boss over there with Nick.
Absolutely. Great job, Charlie. Always happy to have your knowledge and excited that you share all that information with the group here. Shawn, really appreciate you hosting us and having us at the meeting here. And with that, I'd like to pass it back to Jay Cortel.
Hey, thanks, you guys. It was such a pleasure having you both on today. I know today it's been busy and you guys are always having a busy schedule, but this information, as well as any of the previous podcasts, are available. Please feel free to reach out to myself or the individuals themselves, when we always close out by having their information available. I know there's a lot of content, but that's what they're here for. We're here to educate, promote, and help design architectures for our machine solutions applications.
Yeah, I want to thank all three of you guys for coming on. I really have a good grip on your offering here, at least some of your offering. And I really didn't know anything coming into it. So you guys did a really good job. Really love the software, and that it supports so many of the different drives that you offer is just such a home run there. But in any case, thank you all for coming on, and appreciate your time today.
Thanks again, Shawn. Much appreciated.
Thank you, Shawn.
Thanks, everybody.
Well, I hope you enjoyed that episode, and I want to thank Jay, Nick, and Charlie for taking time out of their busy schedule to come on the show and bring us up to speed on Schneider Drives. I learned so much during that episode, especially on those first 3 drives. And if you enjoyed this episode, please give us a like, a sub, and a share. It really is the fuel that keeps us on the air, and I want to thank everybody who does so. I know there's so many of you who do so every week. Thank you, because it's what keeps us on the air. With that said, if you want to join our community or get in touch, you can do so over at automation.locals.com, and you'll also find all of my training courses over at theautomationschool.com. And with that, I want to wish you all an awesome week and encourage you to stay courageous, stay fearless, and until next time, my friends, peace.